Okay, we're going to be speaking about responsive images, and in particular about source set and sizes, those two attributes that can be used with image tags and source tags. But before we do that, I thought we'd start off with a little pop quiz. So who would like to unmute themselves or chat and tell me what a physical pixel is? So yeah, a physical pixel is like the actual physical pixel on your device. And it's got 3 little sub-bits, usually, which represent different colors. And your manufacturer can pack a certain number of them into a certain area. And those are the physical pixels on the screen of your device, whatever your device is. Can anyone tell me what a logical pixel or CSS pixel or device independent pixel is? So it's basically a kind of very, very rough guide to what a pixel might look like generically across different devices. And it's defined a very specific way in the CSS spec, and I couldn't tell you the exact wording, but the idea is to have a sort of standard pixel size that very roughly corresponds to how people experience pixels on different devices, depending on how far away they hold the device from their face, et cetera, et cetera. And it is something that is sort of translated and rendered into physical pixels. So, depending, you create a design, you specify that you need an image in your layout of a certain number of pixels, or a certain percentage of the screen or whatever, and you have no idea what your end user is using. And so their device will translate whatever you ask for into something that's appropriate for that viewport on that device with whatever resolution or pixel density it has. Does anybody want to take a guess at device pixel ratio?
Tom says device pixel ratio is the ratio between physical and logical pixels.
Yeah, so the amount of physical pixels that it takes to display a single device independent pixel. I can figure out how to do that. There we go. Okay, so here is the problem that responsive images are trying to solve. We've got our nice design, and it looks great on our screen. The problem is that on some other screens, it looks like garbage, and that has to do with the size and resolution of the screen or viewport that we're looking at. So, you may design something that looks great on your 27-inch monitor that just looks like absolute garbage on your iPhone X or Pixel 2 or something like that phone. So that's the problem that has existed ever since different devices came on the scene, different devices with different resolutions. And I guess this is a post-2005 kind of problem. So the way it works out is that, on larger screens, when images get scaled up, they become pixelated. Depending on the device resolution, your image can have a size that you didn't expect it to have. It can look much smaller than you were expecting. Say you have like a landscape proportioned image of a person standing in a field or something like that. And on your 24-inch monitor, it looks great. But on your phone, the person is so small that you have no idea who you're looking at. And what you really need in that case is, a much smaller crop of that image. So those are the kinds of problems that we're talking about. Okay. So why don't you just solve this by using really large images and then just scaling those images. You set the width to 100% and load up a really big image, and you're good to go. So then you're just sort of trading one problem for a couple other problems. A lot of mobile devices still have pretty low bandwidth, and so large images load very slowly and burn through bandwidth. And people don't want to spend their data on, downloading your giant image of whatever on their tiny little phone. So that's not going to work. And it doesn't solve that art direction problem that we were just talking about either, where, say they do finally download that giant image of the person in the field. Well, they just spent all that time and bandwidth doing that, and it's still a minuscule little person in a field, and they can't even tell what they're looking at. So that problem is not solved by just using a large image. So what if you used some fancy CSS or JavaScript to swap out different images after your JavaScript detects different things? I guess that could work to a certain extent, but the thing is that your browser is going to parse all of your HTML and start downloading images before it parses your CSS and JavaScript. So that's not going to solve the sort of load time bandwidth issues that we were just talking about. I mean, it could make them worse, actually. If you needed to download 3 versions of an image and then your JavaScript sort of detected what was going on and swapped in the correct version, are you really going to download? No. I mean, art direction is great, but you don't want to download 3 different images and then swap one in depending on what the viewport size is. That's not going to work. Okay. So, so what about the picture and source elements? They're sort of designed to help us out in this situation. And that's true. Together, they allow us to create media queries and to load one of several different images depending on which query condition is being met. But the problem is, in practice, that ends up getting really, really complicated, even in fairly simple use cases. And there's an article that I posted a link to in the chat where a guy goes into like great detail about how you do the math to figure out what kind of queries you would need to do different use cases just using picture and source and the media query attribute in source. So I have one example of that, which is right here. Say you have a large, medium, and small version of an image, and you want to swap in the correct version in your design, which starts out as a single column but switches to a 3-column design on larger viewports, and that you also want to be able to support 1x and 2x device pixel ratio devices. So to do that, you would need the media queries that you see below here. And so what's going on here is that, I can do a little, what you see under within the picture element are 3 source elements, and then at the very bottom, an image element. The source elements each contain a media attribute. And the values that you see in there are the queries that you would need to have contingencies for each of the different screen size possibilities and device pixel ratio possibilities for 1 to 3 columns. And you have to do that for each image. So you have to do it for the large image and the medium image. And then you don't have to do it for the small image because that's your sort of like default, right? And then in cases where the picture element isn't supported, then you fall back to just a regular image. All modern browsers support the picture and source elements. Internet Explorer does not, Edge does. I don't know if Internet Explorer 11 does. I'm not sure. But all modern browsers do. And there is a polyfill for this called picturefill.js. Yeah, Edge does, but yeah, I guess poor IE is back there. But right, oh, and I was saying that there's a polyfill called picturefill.js. So if you have that, if you include that script, you'll be all set for the picture element if you need to support IE or older versions or other browsers that don't necessarily support it yet. So this is still really cool, right? That that depending on whether a media condition is met, you can load different images. And note that so picture and source are something that are happening inside your HTML. They're not happening in your CSS. So this is your HTML being parsed first, and your browser looking at the user's browser looking at the media queries and saying, oh, this is our case. So go get me, server, please give me the medium image or the large image. The problem, though, is that this is only so first of all, this is only a partial solution. It's not a complete solution, and it's super, super hard to do. Creating all of those media queries is just not practical. Really, nobody's going to do that. So
Joe said that the source set in picture should only be used for larger images like the hero images or slideshows on a home page, and the single main page image on an interior page. Do not use responsive image options for page content and smaller icons or graphics.
yeah,
which makes sense.
Yeah, it makes sense not to use them for smaller icons or graphics, I guess. I mean, I guess I sort of thought of this as being more appropriate for images and content than images that might ordinarily be handled as background images in CSS, which is sort of the opposite, I think, of what he's saying. Do you want to unmute yourself and expand?
Can I do that? Does this work?
Yeah.
Okay. Yeah. So the idea is I'm custom building a CMS at work. So I've worked in both WordPress, I've worked in Joomla, I've worked in Drupal, I've worked in all the major content management systems that are available. Plus, we have our own custom built CMS at work. So the thing is, in any content management system, when the content's not added by you as the web developer working for the web development company that builds the template or whatever for the site. The content is added by admin users at the client, on the client's end. They don't have any concept of HTML, CSS, best practices, responsive images. They don't know any of that stuff. We have a slideshow component that an admin user can add any number of slides to. So the slideshow component inside the backend, once you upload an image, it resizes it into 3 main sizes: one at 480, one at 960, and one at the larger side varies, but usually like 1920 for full screen, images. And that's all set up to use source set attribute with a sizes property, or the sizes attribute. We don't use the picture element because, like you said, the picture element is a nightmare. The thing is ridiculous. It's so ridiculous that it's even hard to explain, right? So the idea is, like, when you're adding an image to page content, that's just going to be some smaller image that's going to load fine on mobile devices anyway. Whereas things like a slideshow image, that's going to have to be handled by the CMS to generate the sizes that are needed, so that the user doesn't have to fool with, selecting a mobile version and a tablet version and a desktop version. They shouldn't have to be concerned with that.
Yeah.
Whereas the system should just manage that for them and do it in the background. They don't know any different.
Right.
But what we're doing here in this course is static HTML. Right. We're not dealing with a CMS. There's no logic involved. It's all static HTML. So for our own purposes, it's good to know, all right, I know I've got this giant hero image, my portfolio project, and it's, I don't know, 1200 pixels wide, on the largest size, or maybe it's 2800 pixels wide at the largest size. Who knows where you got the image from, right? So I'm going to take that image into Paint or whatever Mac has, some photo application, and I'm going to size it down to a reasonable size for the desktop. Most monitors run 1920 by 1080. Some Mac monitors, my boss has a Mac monitor that runs like 3200 pixels wide or some crazy thing, some high resolution thing. I'm all the time running into issues with it. So anyway, you just size it down to about 1920 and keep whatever the aspect ratio is so the height looks good. And then from there, just cut it in half. Boom, 960 wide by whatever the height is, and then cut that in half, 480 wide by whatever the height is. And now you've got at least, at a bare minimum, 3 decent images that you can use for a responsive method, whether you want to use the picture element or image tag with source set and sizes. That way, at a minimum, you have that. And then the browser will figure out the rest from there, as long as you set up the code properly.
Yeah, that's pretty cool.
Right, but you only do that for larger images, like actual page content. You wouldn't do that way. It's all done through an editor. We use the tiny MCE editor in our CMS, so which is what WordPress uses as well. So.
Right. Yeah.
All right,
Yeah.
I'm
So
mute myself and let you keep going.
well, the question I have is, so like, if the end user is uploading hero images to different pages or putting images into a carousel or something like that, that logic that you were just talking about is going on behind the scenes for, they upload some really large image, and behind the scenes it gets resized into those multiple different images to account for at least different, not necessarily different layouts, but different screen sizes and resolutions.
Correct.
That's really cool.
It's really complex logic. Like if you guys want to get with me later on Discord or something, I'll show you what the controller and the service looks like to do all of that, because it's thousands of lines of code to figure out. The concept is you want to maintain the aspect ratio, and Cold Fusion has a lot of built-in stuff to help you do that kind of thing with image tags and stuff. But you got to maintain that aspect ratio. But sometimes, depending on, you might be counting on an image to be rectangular, so it's longer than it is higher. But who knows what the end user is going to upload? They might upload a rectangular image that's higher than it's longer. So now when you try to resize that into 1920 wide by, say, 300 high, that's not going to work so well, because it's not meant for that. So our system is smart enough to know that, hey, this is taller than it is longer, so I'm just going to add white space on the sides and fit it down. Like, the logic behind all that is ridiculously complex.
Well, maybe we could get you to do a webinar on it. That'd be kind of
right?
a cool advanced topic for people.
Yeah. I don't want to violate any work issues either. So
all theoretical, hypothetical, right?
Sure.
Cool. Thank you very much.
Yeah, not a problem.
Like I said, we always have a couple of people who have like a lot of experience with this stuff, which is one of the great things about doing these kinds of presentations. There are always people who will share something really interesting. So what I was saying before we got into all of that was that the central problem that we have is that as designers, we know a couple of things. We know how big our image is relative to the viewport, relative to our layout. Within our layout, we know how big our image is. And we know exactly what the dimensions of our image file are. We know the height and width of our image. What we don't know is we don't know what the viewport dimensions are for the user who's going to be seeing our page. And we don't know what their screen density is. We don't know what their resolution is on their device. On the other hand, the end user's browser does know its viewport dimensions, and it does know its resolution, but it doesn't know the image size relative to the viewport until after it's done loading everything. And it doesn't know the image file's dimensions until after it's loaded the image. And so that's the problem that we need to solve. So in the case that we were looking at previously, you know, what we're doing is we're planning different contingencies, right? So my screen seems to be frozen, which is just great. There we go. So all those media queries are planning for different contingencies because of those things that we don't know. So we need a way of telling the browser the things that it doesn't know, but that we do know. And that is what source set and sizes allow us to do. So they sort of, for the end user's browser, they fill in sort of the missing pieces of the puzzle by telling the browser what the image size is relative to the viewport in our design, and telling the browser what the size or sizes of our images are. So with that information, the browser can then make an informed decision about which image to request from the server. So in the sort of revised version of that table that we were just looking at, now the browser has all of the information that it needs. It gets the image size relative to the viewport from the sizes attribute, and it gets the image's actual, not dimensions, it gets the image's width from source set. So the way it works is source set gives like a series of image name and path and width pairings. So you'll get like an image name with a width, and then another image name and a width, and another image name and a width for however many images you want to provide for different scenarios. The sizes attribute provides a series of media queries with a width within the layout. So for source set, the width is actually the image's real width. For sizes, the width that you're talking about is the sort of space in the layout that you've made for that image. So what that actually looks like is this. So going back to that giant picture with multiple sources, media query nightmare that we were looking at previously, we were talking about a case where we had 3 images, large, medium, and small, and all we want to be able to do is serve one of those images depending on whether we've got a a full width single column layout or a 3-column layout, and depending on whether we're talking about a 1x or a 2x device pixel ratio device. So all of that code that we looked at previously is now reduced down to the code that you see here. We've got, you know, our traditional image source and alt tags attributes at the top and bottom of this little clip of code, and then in between we've got source set equals large.jpg space 1024W. And the W there stands for width. And it's the actual width of the image that you're talking about. So large.jpg is 1024 pixels wide. And medium.jpg is 640 pixels wide. And small.jpg is 320 pixels wide. And then after providing those different types of sources with their actual widths, we then give the cases where not the cases, but the the cases where they will be used. So we have min width 36M. So at anything bigger than 36M, we get 33.3 VW, which is viewport width. VW is viewport width, if you haven't seen that one before. So it's just saying at bigger than 36M, the space in the layout is going to be 1/3 of the viewport width. And then there's a comma, and it says 100 VW without any media query. And all that's saying is the default situation is 100 VW, or the full width of the viewport. So basically it's saying if you've got something that's more than 36M, then the space in the layout is going to be 1/3 of whatever that space is. Otherwise, in all other cases, it's going to be 100% of the viewport width. And what's really cool about that is that we don't have to mention anything about pixel ratios, right? Because not only for 1x and 2x, but for every single possible pixel ratio that there is, the browser is going to use the information that we've provided to it to decide which is the right image that I want to grab. So here we go with our, I don't know why that's there. I think I left it there by mistake. Whatever. So here's another example that comes straight from Mozilla Developer Network's responsive images article, where we've got 3 different versions of an image that are helpfully labeled and probably came out of Grunt or Gulp or whatever, having been processed that way to have those suffixes. 320, W, 480, 800. And then under sizes, we've got, in the situation where we're at a screen that's 320 pixels or smaller, the space that's going to be provided for the image is 280 pixels. For screens that are between 321 and 480, the space that's going to be provided is 440 pixels within our layout. Anything else, anything bigger than that, is going to be 800 pixels, which is probably like the full width in this case.
Hey, Julian.
Mm-hmm.
So Alonzo was wondering, how about scale image versus min width image? Like if you try to scale an image to screen.
What about it?
The differences between those two.
Yeah, so you can scale. So the difference there is that you can still do that, but you want to be able to provide different images, because this 320 pixel wide image is going to be a lot smaller and a lot faster to load than that 800 pixel image, right? And you also want to be able to say, you know, if I'm on a 2x device and I have, you know, a 400 pixel space to fill, well, then in that case, I'm going to want the 800 pixel width image, right? And so just using min and max width to, you know, to set limits on the size of an image or setting width to 100%, that alone is not going to get you the benefits that you want to have. Did that make any sense? If there's anyone who thinks they can explain that better than I just did, please feel free to jump in.
Alonzo said it made sense. Scale may have a gray effect. I don't know if that's what he wanted to write. And great, probably. And Vasudeva said, how would I know that the available size is actually before that, sorry, there's another one there. T-Man wanted to know, are you the one to resize the image width to different sizes or just one picture, then you choose your different image widths?
Are you the one? So when you're setting it up, if you're starting with a single image, then yeah, you're the one who is, or in the case of, I think it was John who was talking earlier, you know, his CMS is set up to take an image and then resize it automatically, and you can automate that kind of stuff with Grunt and Gulp and other task runners as well. So yeah, you're taking an image and you're providing different sizes of it that can then be served depending on what the browser tells the server it wants. Is that what you were asking?
We'll find out. And then Vasudeva said, how would I know that the available size is 280 pixels when the screen is lesser than 320 pixels?
Because that's how you designed it. That when you set the size, that's your breakpoint, right? So the size here corresponds exactly to the breakpoint that you set in your design, right? So yeah, that's an important point. Thank you. I didn't say that explicitly earlier. The sizes, the values of the sizes attribute, that corresponds exactly to the breakpoints that you set. So you set a breakpoint at max width 320 pixels. So you made your design to look a certain way at 320 pixels or smaller. And then you have another bunch of CSS that you created to make your design look a specific way between 321 and 480 pixels. And then you have another bunch of CSS that you use to specifically set up what your design looks like at greater than 480 pixels. So yeah, you're doing all that stuff by setting the breakpoints in your design and using media queries in your CSS. And then these sizes in your image tag are going to correspond to those breakpoints. Sorry, I didn't say that explicitly earlier because that's an important point. Did that make sense what I just said? Did that answer your question?
They didn't say anything yet.
Okay. We might get kicked out of this again because I just got a little pop-up that said we only have 10 more minutes.
Yeah, this meeting was self-destruct in 6 minutes. 40
right.
seconds.
Okay, so we might have to pop back in. Have we really gone for 40 minutes? Is that the truth?
Yeah, we started at like 9:18 or something like that at this point.
Okay. Well, I'll pop back in. So okay.
So Vasudeva said, what if the width is set to 100%?
That's fine. You can set the width to 100%, and then within certain ranges, the image will resize. But then you can still set breakpoints, right? So you can have your width set to 100% for your image, and also have breakpoints. That's fine. And then within certain ranges, you can your image will scale to be 100% of the parent element's width, whatever that is, if that makes sense. Okay.
One thing really quick. I don't mean to cut you off.
No, please.
You can't use I mean, you can. Okay. The problem I have is that on MDN, if you look at the source set documentation, one of their examples, in the size as an attribute, they have some media queries, and it says 100%. And the problem is that won't validate through the W3C validator. It'll throw an error. You can't use percentage values in the sizes attribute. So if you're talking about using width set to 100% on the image width, then I'm assume that you mean in your CSS, like you can target a class and you can set width to 100%, height to auto. And in that case, then if you go watch my third video, I kind of explain how that works on the hero image towards the end. In that case, that what Julian said is right. The image will always be 100% width of the parent container, whatever that container is. And then it will always scale. Like if your parent container is the body tag, for example, then your image will take up 100% width of the body. And as your screen size gets to larger proportions, because not every monitor is 1920 by 1080, most are, majority of them are. Some monitors are much larger, and you don't know if a user is viewing your website on a 72-inch big screen TV that they can connect to their computer or stream it from their phone through their TV or something, right? So in that case, then the image gets really large, and the height will maintain that aspect ratio, and that might be the only thing that you see on the screen because it's just
assuming that person was thinking about in their CSS.
And then T-Man wrote something. He said, I want to make it a bit clearer. So you have the alpha variant JPEG image. Did you scale this image to different width of your desired breakpoints, or you will have to edit each alpha variant JPEG image for each width? Example, like the 360 width or the 480 width.
Yes, great. Okay. Yes, you have to create different versions of the Elva Fairy image. Fortunately, you don't have to go into Photoshop and export, resize, export, resize, export. It can be automated. There's like a image editing program called Image Magic and another one called Graphics Magic that you can use in combination with a task runner like like a shell script or like a grunt or gulp plugin to automate the process of resizing your images. So that's a whole other topic of doing that. But the responsive images course on Udacity does go into that using Grunt, and I did do that, and it was not too difficult. Well, I shouldn't say that. It took a while to set it up, but I did it. So you can too. Yeah. So that's the skinny on that.
Roderick just posted a link to a website that will let you scale images, I believe.
Oh yeah, that's the imagemagic.org. Yeah. Cool. Okay. Oh, I was going to quiz you. I'm sorry. Right. So the whole point of this was to ask which image will be requested from the server if your device is a 1x device pixel ratio and has a viewport width of 480 pixels. Does anybody want to chat in which of these images will be served? Which of the 3 images in source set is going to be served in this scenario? Does anybody want to take a guess?
I'm waiting to see if anybody will type it in. William wants you to repeat it.
So
Your question.
if you have a viewport of 480 pixels on your device, and it's just a 1x device pixel ratio device, no fancy high resolution, which of the three images in the code below is going to get requested by the browser in that situation, given the code that's down there?
T-Man said 480 in sync. So answers that were given were 480, and then another person said 440.
Okay, cool, excellent. So the correct answer is 480, and bear in mind that in terms of the images that we only have a 320 pixel, a 480 pixel, and an 800 pixel image to choose from. There is a 440 pixel space in the layout. So the person who gave that answer correctly identified that we're dealing with the max width 480 pixel use case, and that in that case, we've got a 440 pixel space. But what's going to happen is the browser is going to say, okay, well, the image that's closest to 440 pixels is the 480 pixel wide image. So that's the image that I'm going to request from the server. And then once I get it, I'm just going to scale it down a little bit to fit into the 440 pixel space. Cool. Okay. And I did a couple more of these. Which image will be requested from the server if your device has a viewport width of 900 pixels? It's just a 1x device pixel ratio device with a viewport width of 900 pixels. Same code down below. Does anybody want to take a guess as to which image will be served in this case?
Rebecca said 800. William said 800 also.
Very fast and confident. Yes, that is correct. The 800 pixel image will be served.
They got it out there before you were done talking.
Bam. Business. Okay, so here's a twist. Which image will be requested from the server if your device has a DPR device pixel ratio of 2x and a viewport width of 400 pixels?
Rebecca's like 800.
Is that right? I have to actually look and figure it out. I can't remember. Max width 320 is 280. Max width 480 is 440. Yes, that is correct. Woohoo!
Really play Jeopardy.
All right.
I think that would be fun.
Now we're cooking with gas. All right. All right. So which image will be requested from the server if your design calls for? All right. So this is a little different. If your design calls for a 320 CSS pixel image, and your device is a 2x device, look at the code below and tell me which image is going to be selected. The code below is a little bit different. You're going to notice that the sizes attribute is missing. And instead of having 320W or 480W or 640W, you're going to see that on the first image, there's nothing, right? It's just source set elderferry 320.jpg. On the second one, there's a 1.5x, and on the third one, there's a 2x. That's an alternative notation, right? So that instead of providing the width of the image, you're providing the pixel ratio at which you would like that image to be served, right? So given that your design calls for a 320 pixel image and you're on a 2x device, which of those images do you think is going to be served?
I have a couple guesses for 640.
Yes, that is correct. 640. Woohoo! So here, yeah, we're just saying we don't care actually what the what the size is. It's going to be the same size as far as the user is concerned in every case. We just want to be able to take account of different resolution devices. And we're not messing around with, you know, a fully responsive design. It's going to look the same to everybody, but it's actually going to be a different image depending on whether it's a 1x, a 1.5x, or a 2x device. And so this is the last slide, and I just wanted to end with this. This is just, you know, going back over Chrome DevTools and how to check whether you've actually succeeded in writing your source set and size attributes correctly. What you're going to want to do is you're going to want to select the device emulation mode, and then under the network tab, you want to make sure that you have checked off disable cache. I circled all these things on this image. And then you can just have, you know, all, or you can click on the image filter to see just the images that are being loaded on the page. And this is where you can actually see what's the size, the kilobyte size of the image that's being loaded, and how long is it taking. So you'll know the weight of your images. You know how big each of your images is. And so here's where you can see, did it load, you know, the 320, or did it load the 640? This is where you're going to be able to tell that. So I just wanted to close with that, because otherwise, how are you going to know if any of this stuff that you're doing is working? Sometimes it's obvious from looking, but not always. So this is a good way to check. And I think with that, we can sort of wrap up. Do people have questions at this point? Let me sort of swap out my screens again.
We have 0 questions right now.
0 questions.